if you've done enough questions of binomial expansion, you can like pick out one particular term. Because you know what the binomial expansion is like, because you know how to get each term, you can single out one and make use of that depending on the question. So for example, it says find the coefficient of x to the power 4 in the binomial expansion of 2 plus 3x to the power 10. You don't have to do the whole expansion to find the x to the power 4 term. You know that in 2 plus 3x to the power of 10, your a is equal to 2, your b is equal to 3x, and your n is equal to 10. Right. You want the x to the power of 4 term. So you want 3x to the power of 4. Right? Which means you're going to be using 10, 4, and your 2 is going to be to the power of 10 minus 4, 6. And now you just plug that into the calculator. So this gives you 210, this gives you 64, and this gives you 81x to the power of 4. And you're just going to times them together to give you 1088,640x to the power of 4. I didn't have to do the whole expansion for that. So do you see what I mean? You can pick out one term depending on what the question is asking you to do. That is a very simplified question. It's not necessarily going to be that straightforward. Obviously, it's A-levels, they're going to make it hard, right? So in part B, it says find the coefficient of x cubed in the expansion of 2 plus x and then 3 minus 2x to the power of 7. Right, this is where it's a little complicated because you're going to have two instances where there's an x to the power of 3 term. The first instance is going to come from just that expansion, right? If you've got it to the power of 7, you're going to get an x to the power of 3 term. But the other instance is going to come from doing the 2 plus x bracket multiplied by the x squared term on the bracket on the right. So to find the coefficient of x cubed in the binomial expansion of that, you're going to be adding those two together. Does that make sense? So here's what I want you to do. I want you to first just do the expansion of 3 minus 2x to the power of 7 up until the x cubed term. So you should have done 3 to the power of 7 plus 7, 1, 3 to the power of 6 times minus 2x plus 7, 2, 3 to the power of 5 times minus 2x squared, and then 7, 3, 3 to the power of 4 minus 2x cubed. When you simplify that, you get 2187 minus 10206x plus 20412x squared minus 22680x cubed. And then it's just going to go on from that. So that is the expansion of 3 minus 2x to the power of 7. That is one bracket. You have another bracket, 2 plus x. You don't have to... What I want you to do is expand that now for me, please. You don't necessarily have to do every single one. You know you want the x cubed terms. So you're going to do this times that, which gives you an x cubed, and this times that, which also gives you an x cubed. So what do you get? The yellow arrow will give you 20412x cubed. The red arrow gives you, what does it give you? Let me type it in. 22680 times 2. Minus 45360. And now you're going to minus them. 20412 minus 45360, which gives you minus 24948x cubed. So the coefficient is minus 24948. That's your answer. And in part A, they were asking for the coefficient 10888640. That's your answer there. Here, that's your answer there. So that's how that works. You can pick depending on the question. As in, you can pick what part of the binomial you want to use depending on the question. Okay, so the next one. It says, write down the first three terms in ascending powers of x for the binomial expansion of 1 plus qx to the power of 8, where q is a non-zero constant. So can you try that for me, please? Can you just try doing the first three terms? So your a equals 1, your b equals qx, your n equals 8. So 1 to the power of 8 plus 8, 1 to the power of 7 times qx plus 8, 2, 1 to the power of 6 qx squared. So 1 plus 8qx plus 28q squared x squared. Those are the first three terms. Okay, then it says, given that in the expansion of 1 plus qx to the power of 8, the coefficient of x is minus r, and the coefficient of x squared is 7r. Find the value of q and the value of r. The coefficient of x, according to our binomial, which we did in part A, is 8q. In part B of the question, they've said that that is equal to minus r. And in the other case, our binomial says we get 28q squared as our x squared coefficient. And in part B, it says that's equal to 7r. Now what you've got is a simultaneous equation. So can you try and solve that for me, please? Right. So 28q squared equals 7r. So that means r is equal to 4q squared. So if I take that, 4q squared is equal to r. So if 4q squared is equal to r, that means minus r would be minus 4q squared, right? So then 8q is equal to minus 4q squared. 4q squared plus 8q is equal to 0. Factorize it. 4q, q plus 2 equals 0. That means q equals minus 2, q equals 0. In the question, it says q is a non-zero constant. So can't be this one, can only be minus 2. And when q equals minus 2, r equals 16 by subbing it into one of the equations. Okay, that's how that works. So this question, I want you to try on your own. Can you give that one a shot for me, please? Part A. You want to find the first three terms. A is equal to 1, B is equal to px, n is equal to 11. 1 to the power of 11 plus 11, 1 times 1 to the power of 10 times px. And then term number 3 is going to look like this. So 1 plus 11px plus 55p squared x squared. Part B. Find the first three terms in the same expansion are 1, 77x, and qx squared, where q is a constant. Find the value of p and q. Find the value of p and the value of q. Okay. They've said this is our expansion, and their expansion in part B is 1 plus 77x plus qx squared. The coefficients are the same because it's the same expansion. So 1 equals 1. 77 equals 11p. And 55p squared equals q. 55p squared equals q. So what does p equal here? 7. Plug that into there. 55 times 7 squared equals q. So q equals 2695. There we go. Done. That is how you solve binomial questions.